All right, ladies and gentlemen, today we're going to be looking at some quadratic vocabulary. So there's going to be quite a few pieces that go along with this. So you are going to want to write this down. You are going to want notes, of course. We've already been working with so we're going to talk about a quadratic function and what it is. This is a function that can be written y equals ax squared plus bx plus c. And we've already been working with these. And in this case, a cannot equal 0. It can equal 1 or any other value, but not 0. So when we talk about the standard form of a function or of a quadratic function, it actually looks like this. F of x equals ax squared plus bx plus c. Now, just like when we had a linear situation, there was a parent function, we also have parent functions when it comes to a quadratic. This can be f of x equals x squared. It's like the most basic quadratic there is, or it could be y equals x squared. Either one of these, remember, f of x means y. F of x is your input, and the x is your output. I said that way wrong. Y, f of x is your output, x is your input. Now, when we graph a quadratic function, this is what it looks like, and this is what it's called. So a parabola is the graph and we would call it a U-shaped curve. So it's not a V. Notice it doesn't go to a point. It actually has a curve. So when we talk about the graph of a parabola, the graph can have a maximum. So when we have a parabola, so for example, let's say this is our x and y axis. We'll make this my parabola. So this would mean a maximum. So this would be your max. That means it opens down. We can have the opposite of that. And this would be a minimum. Sorry, I was getting a phone call on my iPad. Not even sure how that happens. But you can get a minimum and it opens up. All right, so now when we talk about the vertex is exactly what you think it is, but it's not technically a corner. You're usually taught a vertex is a corner. In this case, it's not a corner. It is the highest or lowest point on the parabola and the axis of symmetry, I'm running out of room, is the x value. And we'll look at this here when we get to axis of symmetry. So you know you have a minimum or the parabola has a bottom to it, I guess I should say, when a is greater than 0. This means the graph opens up. For the next one, it says a maximum would be that it wouldn't be greater than, it would have to be less than 0. And that means the graph opens down. Now we're going to come back and find the vertex, but in order to find the vertex, you need the axis of symmetry and the y value, and we'll look at that here in just a moment. But be sure to write all this down. All right, so here's our axis of symmetry. It is exactly, well, axis is not a familiar word, but symmetry. If something is symmetrical, it's the same on both sides. So this is the line that divides a parabola into two equal halves. So it's imaginary, it's not. So here would be this, like if this were our parabola, the axis of symmetry would be a line that goes right down the middle there. So it would be the same distance on both sides here. So if we're going to be finding our axis of symmetry, we need a point, or the x value. So what we're going to do is use a formula. The formula is x equals negative b over 2 times a. So x equals negative b over 2 times a. And remember, going back to that standard form, ax squared plus bx plus c. So we're basically going to be pulling those values from the equation. So here, let's go ahead and substitute using the one that's below here. So this would be negative 2, so the opposite of negative 2, over 2 times 1. So in this case, the opposite of a negative 2 would be positive 2, right? And 2 times 1 is 2. So this means our axis of symmetry is at x equals 1, okay? So now I'm going to go back to that 1. So now go back to the vertex. So here, the axis of symmetry is the x value. So we found that the axis of symmetry is 1. So that means the x value of the coordinate is 1 for the vertex. Because remember, vertex is always going to be xy. So we know that x is 1. So what we're going to do is substitute a 1 for x. So we have f of 1 equals 1 squared minus 2 times 1 plus 3. So we have 1 minus 2 plus 3. So 1 minus 2, because we're working from left to right, is a negative 1 plus 3 equals 2. There that is. So our vertex is 1, 2. All right, now the last thing I can see my vertex is 1, 2. What we're going to look at is the y-intercept. Now this is where the graph crosses the y-axis. So the parabola, actually it could be any graph. Let's go ahead and say that, because we'll say the graph crosses the y-axis and x equals 0. So the way we would find this is we would substitute x equals 0. So f of 0 equals 0 squared minus 2 times 0 plus 3. So basically that's 0, 0. So f of 0 equals 3. So that means the y-intercept is at 0, 3. So let's actually take a look at this, and we're going to graph this on Desmos, because we're going to get to use Desmos with our graphing. Exactly what we had here. So let me switch to this. So let's see, we have, I'm going to use y instead of f of x equals, x squared, so x squared minus 2x plus 3. So we have a couple of things we can look at here. First of all, our vertex. So this is the vertex, is 1, 2. So when I go back, the y-intercept, let me switch tools here, maybe, not gonna work. Well, you can see on the graph, we don't even have to switch it. It's from here, it's up 1, 2, 3, so it would be 0, 3, which is so you can also see that the axis of symmetry is here, which is where x equals 1. So there's a lot of different things that we are going to be using and learning from a graph of a quadratic.